continuing on with functions, we're going to be looking at graphs of functions. So when we're looking at graphs of functions, we're first going to start off with how to graph a function. Okay, so they'll give you a function and then they'll give you a domain and you just have to plug it in and actually graph it. For some of them, there'll be equations of lines and we know how to graph those. Okay, but say for instance, it's something else. Let's say for instance, I have f of x equals the absolute value of x. And they tell us that my domain is -2, -1, 0, and 1. Okay, so what that means is I'm going to plug in the -2, the -1, the 0, and the 1 and figure out what I'm going to find. So it's kind of like our T-chart when we were working with how to graph. It's similar to that. I know some of you like the H-chart, which is fine. So I'm just going to rework this here. So I know that I have the absolute value of -2. Well, the absolute value of -2 is 2. The absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. So now I've got a domain and a range, and I can use that then to graph my points. Because remember, a domain and range is an ordered pair because it's a relation. And we know that a domain are my x values and my range are my y values. So I'm going to go ahead and just plot those points. Now, you can just leave it like that, or you can actually connect the dots. I would connect the dots. Sometimes you will have a curve, but with an absolute value, it is in the shape of a V. So that right there is the graph of my function. F of x is equal to the absolute value of x. Okay. Now, this isn't something that you guys can really answer a multiple choice question on. So we're just going to move on then to the next part. So this, they've already given you and told you that the function was this, and they've given you a domain. But let's do the opposite. Let's look at, okay, if I'm given a graph, how do I know for sure that it's a function? There is what we call a vertical line test. So what the vertical line test does, it tests whether or not you have a function. If the graph touches or intersects the vertical line more than once, it is not a function. Okay, so that's a lot to take in. So we're going to look at some examples here. I'm going to have two separate graphs here. All right, so looking at this, I've got two separate functions here. They're both graphed. So I'm going to use the vertical line test to determine if, in fact, it is a function. So what does that mean? That means if I were to draw vertical lines all the way across this, looking at just one vertical line, so I'm looking over here at the far left one, how many times does the red line cross that vertical line? Once. Okay, move on to the next vertical line. How many times does the red line cross that vertical line? Once. Move on to the next one. Once, 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 once. So this first one, it is a function. So now let's look at the second one. So I'm drawing in some vertical lines here. Let's look at this first one. Looking at it, the red line doesn't even intersect it, so I don't even have to worry about it. So that one's good. Let's look at this next one. So I'm looking at it, the red line intersects once and twice. So right there, I don't even have to look at the other vertical lines. I already know, not a function. And that's all based on my vertical line test. So you're going to have two questions based on this concept. Question 1, is this a function? Looking at this, I go ahead and draw in my vertical lines. I already know, looking at the first one, it is not, because it intersects twice. How about this next one? Is this a function? This one's kind of hard, just because we haven't really seen anything like it before. Looking at it, I see 1, 1, 1, 1, 1, 1, 1, and it keeps going as 1. This one is in fact a function.